Hello, my pre-calculus student. In this video, we are going to review the graph of sine, cosine, cosecant, and secant function. So let's begin with the first graph. In this graph, you can see the value of our y will repeat itself for every 5 value y equals 0, y equals 1, y equals 0, y equals negative 1, and y equals 0. And again, it just repeats itself. Y equals 0, y equals 1, y equals 0, y equals negative 1, and y equals 0. So first we start with the period. So in this case, the period is the horizontal length for one complete pattern of the y values. In this case, be 2 pi. The amplitude is half of the distance between the max and the mean, so amplitude is 1. Domain will be the collection of all the x value. So in this case, I will use the set builder notation. So this is the collection of all the x values such that negative infinity less than x less than positive infinity. Or you can use interval notation, be shorter. You can write like this. The range, again I will use the set builder notation, the collection of all the y values such that now we know y mean is negative 1, y max is 1, so be negative 1 less than or equal to y, and y less than or equal to positive 1. Or we can use the interval notation. We have to use the square brackets because since we include our negative 1 and positive 1 in the interval, the y-intercept is 0. The x-intercept, now we can see right here that the x-intercepts, there will be more than one x-intercept. If I just look at one period from 0 to 2 pi, we have 3 x-intercepts, x equals 0, x equals pi, x equals 2 pi. So it is a multiple of pi. So therefore, the x-intercept, we can write them as, let me write them as an equation. Or you can write set builder. I'm going to write an equation. So say the x-intercept would be equal n times pi, where n belongs or is an element of the set of integers. So z is set of integers. So n can be 0, 1, 2, 3, or negative 1, negative 2, negative 3, so far so on. And lastly will be the symmetry. In this case, the symmetry is the point 0, 0. So therefore, we can conclude that this is arc function. Now let's look at the next graph. So first with this graph, we can see that the pattern of the 5 y value be y equals 1, y equals 0, y equals negative 1, y equals 0, and y equals 1. Again, just repeat the 5 y value again. Y equals 1, y equals 0, y equals negative 1, y equals 0, and y equals 1. So therefore, we start with the period. So the period in this can be 2 pi. By the way, for the last graph, make sure that you copy the graph to your note before you describe the graph. And we have not determined if this is the sine, cosine, cosecant, secant, or cotangent. First of all, we know that this is not cosecant and secant because they don't have any asymptote. So it must be either sine or cosine. So what is the difference between y equals sine x and y equals cosine x? Y equals sine x, which is the parent function of sine you can see that there are 3 x-intercepts. So there are 3 x-intercepts, so therefore we conclude that this is the sine function, y equals sine of x. So this is just the parent function. It's very simple and basic function. Now next we're going to go back to graph number 2. If you can just copy the graph, amplitude is half of the distance between the y maximum and the y minimum. So amplitude is 1. Domain. So domain again, all real number. Now I'm going to go ahead and use the interval notation. The range. Our y value go from -1 to 1, and we have to use the square brackets because we want to make sure include the -1 and 1 to our interval. The y-intercept. So in this case, the y-intercept is 1. The x-intercept. Now you can see right here that for each period there are 2 x-intercepts, and they are at multiple pi. So how can we write that at multiple pi? Because this is 1 pi over 2, 3 pi over 2. So 1 and 3 they are odd numbers. So the next one should be 5 pi over 2. So I'm going to write them as pi over 2 plus n z, where n is an element of the set of integers. Sorry, and pi. So now we have now we need to talk about the symmetry of the graph. So look at the graph. You can see right here that the y-axis is the symmetry of the graph. Symmetry is the y-axis. So if the y-axis is the symmetry of the graph, then this function is an even function. So since we know that the last graph is the sine graph, right? And we know that this graph is not cosecant or secant because it doesn't have any vertical asymptote. So therefore we can conclude that this graph is the graph of cosine. So y equals cosine of x. Now let's move on to graph number 3. So the first thing you can see that the dashes graph is the sine graph. And then where are the x-intercepts on the sine graph? That becomes the vertical asymptote. So since we only have sine cosine graph, so we can think about this as the reciprocal of sine graph. So what function that will be the reciprocals of sine? It have to be cosecant function. So therefore we can say that this is the cosecant of x. This is the graph of y equals cosecant of x. First let's start with this graph has no amplitude because it doesn't have the maximum or the minimum. So in the graph you can see right here that it goes to the infinity. The periods, but it does have the period. So for each graph you can see the graph of sine have the period of 2 pi, so therefore the period of cosecant would also be 2 pi. Let's go to the domain. So the domain will be the set of all the number x such that the graph of cosecant takes every single numbers on the x-axis except where the vertical asymptotes are. So those are 0, pi, 2 pi on the positive side, and negative pi and negative 2 pi on the negative side. So therefore we can say that the set of all x values such that, so this line means such that x cannot be multiple pi. So n times z, where n belongs to the set or of integer. So that's the domain. Now let's go to the range. The range, I'm go ahead and use the set builder. So you can see that there are two U shapes. Let's start with the one that up and down, the y maximum is -1. So it means that y less than equal to -1. And let's go to the second U shape. The y minimum is 1. So y is greater than or equal to 1. So that will be the range. No x-intercept because the two U shapes, neither of them intercept with the x-axis. So therefore we can say no x-intercept. And also no y-intercept too, because the graph doesn't intercept with the y-axis. Let's go to the vertical asymptote. For the vertical asymptote, it will be multiple of pi, because that is where the x-intercept for the sine function. So therefore x equal n times pi, where n belongs to or is an element of the set of integers. Symmetry is the point 0, 0. Since the sine graph have the point 0, 0 at the symmetry, so the same thing with cosecant will have the point 0, 0 at the symmetry. So therefore cosecant is an odd function. Okay, let's move on to the graph number 4. So far we have the graph of sine, cosine, the graph of cosecant. So this graph, first look at the dotted green curve. This curve is the graph of cosine. So this is where y equals cosine. So therefore this is the reciprocal of cosine. So we can conclude that this is the graph of y equals secant of x. Now let's start with amplitude. The secant function have no amplitude again because the graph doesn't have the y minimum or the y maximum. Periods, it does have the same periods with the cosine function, so this can be 2 pi. Domain. Now we know that the graph of secant function does have vertical asymptote where the cosine is 0. The cosine function equals 0, or where the x-intercept of the cosine function. So that pi over 2, 3 pi over 2, or negative pi over 2, or negative 3 pi over 2. If I just look at 2 periods, so therefore the domain will be all number x such that x cannot be equal odd multiple of pi. So odd multiple of pi over 2. So pi over 2 plus pi times n, or n times pi, where n is an element of the set of integers. So that's it, the domain. Now move on to the range. So again, there are two loops, one open down and one open up. So let's start with the one that open down. So the range will be the set of all the y such that the y maximum is -1. So y less than or equal to -1, and the y minimum is 1. So y greater than or equal to 1. The x-intercept, the graph doesn't intercept with the x-axis, so no x-intercept. However, it does have one y-intercept. So in this case, the y-intercept is 1. Right here, there. Symmetry. Symmetry, you can see right here that the y-axis is the symmetry of the graph. So therefore, we can conclude that the secant is uneven function. So let's write down the summary for this video. So in this video summary, in this video we learned it, or we review the graphs of these four functions: y equals sine of x, y equals cosine of x, y equals cosecant of x, and y equals secant of x. Thank you so much for watching this video. I will see you in class. Goodbye.